Hi everyone, this is Professor Oaks, and in this video I am going to do this problem right over here, graph the feasible region for the system of inequalities. So I'm first going to show you how to do this by hand, and then by using the TI-84 plus calculator. All right, so if I have y is greater than 8x minus 1 and y is less than negative 4x plus 3. I am going to graph each of these separately. All right, so here we go. So let's look at first the 8x minus 1. So if x is, say, 0, I get 8 times 0 minus 1, that's negative 1. So there's a point at 0, negative 1. And then I actually can tell you that the slope is 8, but and the y-intercept is negative 1. But if I choose, say, 1, I have 8 times 1 minus 1. That will be 8 minus 1 is 7. So I have a point at 1, 7. So 1, 2, 3, 4, 5, 6, 7. So 1, 7. And now let me get a ruler here. All right, so here we go. So I'll try to draw the lines as accurately as possible. So remember, for greater than or less than, we need to use a dashed line to symbolize that the values can't be a value directly on the line. Or for greater than or equal to or less than or equal to, we need to use a solid line, all right? So let's go ahead and graph this. So here we go. Oh, and it should be a dashed line. So that's what I just said here. So let me go ahead and just use a little bit of white out here just to make it look like it's a dashed line. All right, there we go. That's dashed enough for me. All right, so this is definitely a dashed line here now. Now let's graph the other one. All right, so we have the x and the negative 4x plus 3. So this has a y-intercept of 3 and a slope of negative 4. So there's a point at 0, 3. And then if we go down 1, 2, 3, 4, and to the right 1, there's a point at 1 and negative 1. All right, so this again will be a dashed line. So I'll try to accurately represent this right now. All right, so this is also a dashed line. Now, we'll get to the shading part in a moment, but I think that it might help to know where that intersection point is. So if I set 8x minus 1 equal to negative 4x plus 3, then I can add the 4x, so 12x minus 1 is equal to 3, then add the 1, so 12x is equal to 4, and then I divide by 12 to get x's 1 third. All right. So then at 1/3, this is 8 times a third minus 1. So that is 8/3 minus 1. That's 5/3. And you can verify that over here for 1/3 negative 4 times a third plus 3, that's also 5/3. So this point where they intersect is 1/3, 5/3, all right? my point is a little bit bigger than it needs to be, but I think that you get the idea here. Now, all right, remember that this first one that we drew was the y is greater than 8x minus 1. And this one right here was the y is less than negative 4x plus 3. All right, now, what we want to do is, for the one that was greater than, right, see how the line actually goes like this, right? Since with y is greater than this, here are all of the y values are bigger than the values on that line. All right, if we wanted the ones that are less than, then we would choose all of the y values down here that are less than the values on that line. So since we want greater than, we want to shade over on this side of the line, all right? So I'm going to try to make this as accurate of a depiction as possible, but you know, I know that my drawing here is not going to end up in the DIA or anything like that, at least not anytime soon, at least. All right, and now for this next one, we have y is less than negative 4x plus 3. So again, yeah, so if we want it less than that line right there, it would be all of the y values that are lower than that line. If we want it greater than, it would be all the values that are bigger than that line, all right? So since we want the values that are lower than that line, that would be all of the values over here. And then the solution is actually, the solution that you would actually enter in the computer as the feasible region would just be the region where the shading overlaps. So your final answer should just look something like this. All right, so, and this is why I normally would just use a pencil and erase the parts that maybe didn't overlap, but for the visual, I think it helps, although that color mixed together looks really bad. So the first one had a point at 0, negative 1, and at 1, 7. So it looks like this. And then the other one had a point at 0, 3, and at 1, negative 1, so it looked like this. And then we know that the shading that overlapped was over in this area right here. And so this is the solution. All right, now, if I were to do this on a TI-84 plus calculator, so let me bring one up right now. All right, excuse me. So then here's what I would do. I would, well, first of all, turn it on and then go to y equals. And then the first one was let me bring it down here. It was y greater than 8x minus 1. So I actually go over here, arrow over to that little symbol right here, and then arrow until I get the little triangle pointing upward to indicate the shading need to be the greater than values. All right, so I really think that you can do, I don't think that you can do the shading with the dashed line on these quite yet, but I think that you have the idea. Then hit, oh, sorry. Okay, then enter the 8, and then the 8, and then the x minus 1, and then go down, and in the y2, do something similar for y is less than negative 4x plus 3. So arrow over to that little line here, and then hit enter and arrow down, and then look for the one that looks like the triangle pointing downward for less than, and then hit OK. Then arrow over and enter in -4, x plus 3. And then I'll graph this, and you can see that this is the area where the shading overlaps, so that was my solution, all right? So it might help to know how to draw this by hand in a way, but at least the calculator can verify that you've shaded these regions correctly. So I hope this helped, and thank you, and have a great day.